So electron configurations, it's like looking at a map of the element world. Okay, the element world is broken up into neighborhoods. Okay, we have the S neighborhood, the P neighborhood, the D neighborhood, and the F neighborhood. On the S neighborhood, there are 7 streets. We have street 1S, 2S, 3S, 4S, 5S, 6S, and 7S. Those are our streets in the S neighborhood. Each box represents a house where an electron lives. Okay? We don't have more than 1 electron in each house. So on street 1S, there are 2 houses, 1S1 and 1S2. That's the address of those electrons. Okay? On street 2S, there's, once again, 2 houses. The S neighborhood only has 2 houses in each street. The P neighborhood has 6 houses on each street. And their street numbers follow the period numbers. So if I'm on 2nd Street, I'm on 2P. 2P in the first house. So this right here is 2P1. Okay. Then we have 2P2, 2P3, 2P4, 2P5, 2P6. These are their house address. We have the street number, the neighborhood name, and how many boxes down it is. When we're over in the D block, they have several houses in each one. We have 10 blocks, 10 houses in each one. Now, the numbering on the D block is a little bit wonky. Kind of like driving around Houston. One day you're on 4th Street, and all of a sudden you're on 3rd Street. That's what happens in the D block. So notice how it says 4 over here, but when you get to D neighborhood, D is 1 number up. So this is 3D Street, and we have 10 houses here. 4D Street, 5D Street, 6D Street. The F neighborhood is very wonky. It's off by 2. So you're driving down 6th Street, you won't go through the S neighborhood, and you immediately hit the F neighborhood, and now your 6th Street is 4. So yesterday we talked about trying to find the directions to each one of these elements. Today I just want to focus on that exact address. If I say fluorine, you need to be able to tell me where's the address of fluorine. So fluorine falls right here on the periodic table. So fluorine lives on 2P Street, and he lives 1, 2, 3, 4, 5 houses down. So fluorine is 2P5. But uranium's a bit different. Uranium is down here, 4 blocks over. Uranium lives on 5F Street. He lives 1, 2, 3, 4. So his address is 5F4. Today we're going to be playing Battleship, and you need to be able to say these coordinates. Say what the address is and what element is there. If you don't match them up correctly, you lose your turn. So if I said fluorine is 2P7, because I started counting here wrongly, you start counting here for the houses on that street, right? So if I said it was 2P7, I said fluorine 2P7, the person I'm playing against to say, I'm sorry, those two don't match up. I can't tell you if you hit or miss. So you miss that turn. Now they're 1 hit ahead of you. They're probably going to beat you. Okay, so you got to make sure you can match this element name and its electron configuration. Flip to the periodic table in the back of your book, and we're going to label these neighborhoods. So you need 4 colors of highlighter. The first thing we're going to do is label the periods. Now, where a period is easy to remember, because when you write a sentence, you go left to right, and you end it in a period. So my periods go left to right. Now let's number our periods. 1, 2, 3, 4, 5, 6, 7. I have 7 total periods. There's only 7 possible electron shells. Now we're going to label each of our neighborhoods. So my first neighborhood is right here. Now only do the outside of the whole neighborhood, because we're going to have to color in the families that live inside these neighborhoods later. So just highlight the outside. This is the S neighborhood. Each S street has 2 houses. Now notice how I left a blank spot right here? That's to remind you, go over here and highlight helium. Helium still lives in the S neighborhood. He's just way, way, way out in the fields behind it. So helium is part of the S neighborhood. Next, we have the P neighborhood. This whole block over here. By the way, these elements down here, if you have them filled in on yours, they're hypothetical elements. That's why they still have the UU. They haven't been named yet. Until somebody can actually make them in a lab and they survive long enough for us to test it, they won't get a name. So they're just hypothetically, these elements should exist. Nobody's seen them yet. That's why they don't exist on my periodic table. 114 has been seen. So that's why 114 is on this periodic table. But you just fill in that whole block, because when we do discover them, they will still have their final electrons in the P block. So this is my P block. It follows the same street numbers as the S block. If you want to redo those, you can do that as well over here. Once again, 2, 3, 4, 5, 6, 7. So there's no such thing as a 1P. There's no 1P street. Now my next street is one of the wonky streets. We have it, it's in our D block. So highlight the entire D block. And our streets are named one off in the D block. We have 3D. 3D is right beside scandium. 4D. 5D. 6D. So there's no such thing as a 1 or a 2D. No such thing as a 7D. So this was our D block. And then our last one is our F block. Now don't forget, your F block should really fall right here on your periodic table. But if we actually put it there, it would make the periodic table really, really large and very, very difficult to print on anything and still be able to read it. So instead, we just cut this really long piece out right here and put it on the bottom. But that's where it goes. So you can't, when you're driving, you actually drive from 6S through, let's label it, 4F. F. So if you were to drive down starting at 6S, you'd go down 6S Street for 2 blocks, then you'd go down 4F Street for 14 blocks, back to 5D Street for 10, and then 6P Street for 6. If you were trying to get all the way to radon, it's a very long drive. The map would be way too big, so we put this last piece of the map down here.